Hello students, good morning. Today we start a new chapter, that is a circle, chapter number 10, circle. The earlier class in standard 9, you already learned about some basic terms of the circles. For example, that the radius, the chord, center and this arc, sector, these all things you have known. But here being introductory part of the circle, we again revise shortly that things. Okay. As you know, circle. This is a very important chapter, right from the 9th, 10th, 11th and 12th. There is a more concept again you are going to learn in the next year, 11th and 12th also. So here some part of the circle we already learned in the 9th standard. Now here we learn the further parts. See, introduction part of the circle, that we know very well that. You know what is a circle. What is circle? Just remind that what is mean by the circle. It is the locus of point. It is what? Locus of point, which is fixed distance from the fixed point. That is called the circle. What is locus? Locus of point is a path. So in shortly we can say that it is a collection of point which is from the fixed distance at the fixed point. That is called a circle. That fixed distance means what? See, these are the infinite number of points which is in the circular path, and that's why it is this ring look like this one. Actually, this ring is made up by what? The infinite number of the point, that is called the locus of point, which is the fixed distance from the fixed point. It is a fixed point. This is what? Fixed point. If it is O is a fixed point. And here we draw P is any point on the circle, on the locus of the point. So here this PO is a fixed distance, which is called what? Radius. It is what? Radius of circle, and O is the fixed point which is called center of the circle. O is what? Center. Center of circle. Now suppose we take the another point here or here, anywhere on the circle. So suppose we take the point here Q and we join this. So this also the fixed distance from the fixed point. So fixed distance is called the radius and fixed point is called what? Center of circle. Okay. Now see another one. Again, any other thing, suppose this is AB, A and B are any two points on the circle, we join them. So this line segment join AB. This line segment cut circle in two parts. But see, the end of this line lies on the circle. So this is called what? Chord of a circle. Okay, how many chord of a circle? There are the infinite number of chord. Take any two point and join this. This is what chord. How many radius of a circle? Again there are the infinite number of the radius, but center is what? 1, because it's a fixed point. Okay. So this is called the chord. Chord is what? You already know that a two end point lies on the circle. This is called what? Chord. Okay. Now another thing is that this is one of the chord. If I draw here is that also another chord. If I am drawing here also the 2 points, again one of the chord, and here I will draw another chord. Suppose it is XY. XY is a chord, same as the AB also the chord. What is the difference of these two chords? See, first thing is that AB is shorter than the XY, but XY also the chord because X and Y lies on the circle. So, but this chord XY passing through the center of the circle. So any other chord, suppose we draw here like this one. So all the chords are the smaller than this XY. So it is called the biggest chord, which is what? A chord is passing through the center of a circle. That is called the biggest chord. That is the biggest chord, and that biggest chord is called diameter of a circle. Okay. So XY is what? Diameter. And this OX, again what? Radius. OX and OY are what? Radius. So this is R. This is R distributed. So 2R is equal to what? XY. So what? Diameter is equal to 2 times R. That is what? R is equal to D by 2. Radius is half of the diameter, and diameter is a double of what? Radius. So diameter is nothing but a chord, but it is the biggest chord which is passing through the center of the circle. Okay. So these all are the basic things you already know. Okay. Again, what is arc and axis? So A and B are any 2 points. So this length A to B, from A to B, this length is called the arc of a circle. But this A to B also the arc. Suppose we can take A, X, P, Y, B, this length, or A, P, B, this length, and A, B, this length. So these are called the arcs. So this is called the minor arc. This is what? Minor arc. This is the arc. So it is a minor arc, and it is what? Major arc. This also you have known already. Okay. Then again, this AB divide a circle in two parts. This is one of the part, and rest of the part where center is located. Okay. So these two parts of the circle, each part of circle is called what? Segment. So this AB including means the region between the chord and arc. Region between the chord and arc is called what? Segment. Again, this also what? Segment. So there are two segments. So this is the minor segment. It is what? Major segment. Again, the center is included. That is what? Major segment. Okay. Now the next. See. Again. What about the sector? As you know very well that. See, sector means what? Sector is a region between the two radii and corresponding arc. If, see, this is PO is the radius, QO also the radius. So this is the region between the two radii and corresponding arc is called what? Sector of a circle. Okay. So it is another again. So this is also sector. This is also what? Sector. So this is what? Minor sector. This is what? Major sector. Okay. So these are the basic terms of the circles. Okay. What is new here? See. Again. If I draw a line. Now these are our segments. I am writing in the line. If I am drawing such type of line, these lines are not intersect anywhere of the circle. There is no part of circle. If this line goes like this, what happens then? This line touch the circle at one point. Suppose it is what? P. Touches only. Another line, suppose it is line L. This is line M. Line M is passing like this one. And this line intersects circle at 2 points A and B. What is the difference of these three lines? This line is never not intersect. It is not intersecting line with the circle. Line M is intersect a circle at 1 point only. So this P line M is intersect circle at 2 points A and B, and this goes square again. So line M is called second. Second of a circle. Line intersect a circle at 2 points is called a second. And a line intersect a circle only 1 point is called what? Tangent. It is called what? Tangent of a circle. Okay. So here this point P is called the point of contact, because tangent is intersect, because that line which intersect a circle at only 1 point, or we may say that a line touch a circle at only 1 point, that line is called what? Tangent to a circle. And where this line is intersect a circle, that point is called point of intersection. Okay, so like this one. This is second, this is what? Tangent. We learn more about the tangent. Okay, so now we see what is the tangent to a circle. Next part of this one, that is tangent to a circle. Tangent to a circle. See, what is tangent to a circle? That I will explain right now. O is the center of the circle, right? Now here, this line touch the circle at 1 point, that is what? P, line L, or we say the line XY. Line XY touch a circle at 1 point P. That's why it is called what? Tangent to a circle. Now the question arises that how many lines are passing to the point P, or how many lines touches at P? Just try to draw the lines. If you draw the line from here, so we come to know that the conclusion is that there is, suppose one point is on the circle, this point P, so one and only one line is passing through it, means at a one point only one tangent to be there. Okay, so this is there are infinite number of tangents, no doubt. Suppose here is a point, we draw a line like this one, there are so many lines are there, but at a one point of contact, only one tangent to be drawn. Okay, so this is the point of, so means the line and a circle, there is only one point of contact, that is a tangent. Okay, so this is about the tangent. Okay, now see, we more about this one. So what we define the tangents, see, it is in your textbook. A tangent to a circle is a line that intersects the circle at only one point. A tangent to a circle is a line that intersects a circle at only one point, and that intersection point is called point of contact. This is called point of contact. This is what tangent. Is it? So this is nothing but tangent, and this point P is what? Point of contact. Okay, just mind these two terms of this one. What is tangent and what is point of contact? Okay, see again. There is only one tangent at a point of a circle. From the point P, there is only what? One tangent to be drawn. There is no other tangent. Okay, this is. So, what is the difference of tangent and secant? Tangent touches a circle at one point, or we can say intersect a circle at one point, and secant a line which intersects a circle at 2 points. That is called what? Secant. Okay. Now, see here, we go for the theorem number 1. That is from on page number 208, 10.1. See what the theorem is that. It is a theoretical way. Theorem 10.1. That is very important again. It is important theorem. See the statement for that. See, the tangent at any point of a circle is perpendicular to the radius through the point of contact. That we have to prove that. What we have to prove? The tangent at a point, at any point on the circle, this is the tangent xy, at any point on the circle at what? P. Okay. Perpendicular to the radius through the point of contact. This is the point of contact. This is O in center. If we draw, so OP is the radius. What do we have to prove here? OP is perpendicular to xy. Okay. What's the given thing here? O is the center of a circle and xy is a tangent. P is the point of contact. What do we have to prove? To prove radius and point radius where touches at a point of contact, so it is perpendicular. So we got OP is perpendicular to xy. Radius is perpendicular to tangent at point of contact. That is your proof. See, suppose we take any point on xy, Q. Point Q, we take a point Q on tangent xy and we join that. What about the OQ? Can it is a radius? No, because radius means it is that this Q point must be on the circle. So it is a radius. If Q is inside the circle, so it is not laying on the xy. That is another thing. Okay, so Q on what? Xy. Observe that OQ and OP, which is the bigger? OQ and OP, which length is more? Definitely OQ is more than that one. Okay, so here if we join OQ. Now then if we join OQ, what we observe that OQ is more than what? OP. Right? If we take another point which is again nearer to the P but not on P. Suppose this point, it is R. OR and OP. So again OR also more than the OP, right? This is OR is also more than what? OP. You can take any point on this side also, such points. So all these line segments except this OP, all are what? Less than what? OP. So OP is the shortest length. OP is the shortest length than this all the points, all the line segments. So OP is what? Shortest length, and we know that what we call the shortest length is called what? Perpendicular. Shortest length, that is called, we can say the height is perpendicular, but here we can say that shortest length is perpendicular to that line. So that's why this OP is the shortest distance other than this all the line segments. So therefore and shortest distance is called what? Height, that is called the perpendicular. Means what we can write here. So therefore OR is more than the OP. Suppose we can take here the S point. So OS also more than the OP. Means what we conclude here कि OP is a shortest length from O to XY. OP is the shortest length from point O is center to what this line XY, and shortest distance is always what? Perpendicular. So therefore OP is perpendicular to XY. Why it is so? Because shortest distance, shortest length is always perpendicular to that base. So OP is perpendicular to XY. This is the theorem. Is it clear? Go for this. Now see, it is theoretically we have to prove. I already told you that before I started this. See then. Now, if we draw the one circle again, this is what center, this is what your tangent, this is point of contact, suppose A, this is any L, line L is a tangent, and we join like this one, so it is always what? Perpendicular. Is it clear? This is what our theorem. So we can say that the line join radius is always perpendicular to the tangent at the point of contact. Is it? So like this. Just go through this theorem again and try to solve the 10 point, because it is very easier exercises. Only the few things are given here. Okay, fill in the blanks, and that you have to draw the two circles, and then all things are there. So we see that tomorrow we'll see the another part, very important concept of circle. But today we stop here. Thank you.